Welcome to our final lesson of Chapter 1. Congratulations! You are now about to experience the top of our Python pyramid, where we have saved the best for last and are going to look at the nouns of Python in the context of real-world applications. So for this lesson, imagine that you were taking a course from me to be an auto mechanic instead of a Python programmer. This would be the point in the class where we were done learning about the nouns. We would be done walking around the auto garage and simply pointing and naming objects like wrenches, screws, and drills. But as a little surprise, before moving on to learning about how all these tools fit together, wouldn't it be fun to take a field trip? Let's go and look at some classic cars, open up the hoods, look around inside of the engines, and see if we can identify some of the parts that we've been getting to know. So the equivalent of that is my goal with this lesson. Let's think of each Python project, real-world script, as a car, where we pop open the hood and we point out where the pieces that we've been learning about all come together and fit into a real-life application. Bring on the pain, you say. Well, I will. In front of your eyes right now, you see a whole bunch of applications. Applications that can help you cheat on your homework. Applications that can automate the Fibonacci sequence. Applications that can scrape jokes off a website and tell them to you. This is the manifesto. This is the engine of our course. Let's start with a little creative writing, shall we? And remember, by the end of this course, these are going to be the kind of applications you can build. So let's start with speaking. Speaking involves one noun, a noun called string. This is an object, and we can send it to the console using the word print, and we can print bark, which is what dogs do when they like you. Or if they don't like you. It's actually the only thing dogs can do, except whimper, but we never make them whimper. I'm watching you. How about automate boring songs? Anybody sick of 99 bottles of beer on the wall? Take one down, pass them around, 98 bottles of beer on the wall. I'm sick of that song after that one line. So let's automate that. Oh, snaps. But we'll learn about those in Chapter 2. Now let's talk about making interactive jokes. The most important part of programming. What do you get when you cross a snowman with a vampire? It will prompt the user for an answer. And when they say, not sure, frostbite is what they get in return. How cool is that? You're making interactive jokes. And right now we have our input statement, which is a new one. This is going to be a function we're going to learn that's going to prompt the user for input and save it into a variable, which is something we'll talk about in this first chapter. That is an important noun, an object that we will use quite a bit. And I should be careful to say too, because everything in Python is an object. That means something really specific. In this video, I'm kind of referring to objects in the same way nouns are person, place, or things. Things to remember, wrenches that you can hang on the garage wall. Here, we can run this cell over and over and over again. And every time, it's going to pick a different letter. So you can imagine how cool it'd be to build some kind of an app where you're like randomly generating some kind of, color or name or coin or something like that. How about identifying a position? So someone's like, I can't tell you where that code word is because that's a secret code word and you'll never find it. Oh yeah? Well, we can write a function, which we're going to learn about in Chapter 2. We have a variable noun. We have a method, which is an action, but it's being applied to another noun, which is our argument noun, something that will be passed in. And then it's going to be returned with a keyword. Then we're going to be calling this function down here by passing in two different arguments. And both arguments are objects. And even though these look different, they're both exactly the same type of object. They're both strings. But up here, we're saving the string into that variable to go around. And of course, remember, we're going to learn all of this step by step. Great minds discuss ideas, and small minds discuss sardine pizza. I know. Bet you didn't believe I wrote that. I did. So 33, interesting return. What does that mean? Well, if you go 33 characters in, you will start the word mind for the second time. And you can see here, that's exactly what we wanted. We wanted to search that string and find the word minds the second time. That's why we added +1. Did a little math right there. Great noun to know about. Talk about removing vowels. Who here is sick of complete sentences? I know I am. Also remember that when I'm talking about nouns, that's like not a programming thing. That's just part of my analogy to compare the programming language with the English language for contextual reasons. How about we remove some vowels? Check that out. Has anyone seen that whistle? It's silver. Now it says hisninsin this whistle tis silver, right? Makes way less sense. So, when you learn to program, you have the ability to ruin sentences in a maximum ruined way, which is totally going to anger people who love English. Another good reason to learn programming. How about reversing a string? Pretty fun. A lot of good movies have the main character with a reverse name that's revealed at the end. The one in Westworld. Now you have a tool. You can simply put the name into our reverse text program here, and it will take a word like booby trap, and it will put it into a variable, another noun that we're going to learn a lot about, another one of the type string. Then we're going to learn about a count variable, which is actually an integer, and we're going to learn about assignment. And in chapter 2, we're going to learn about ways we can use assignments and also shortcuts so that we can decrement numbers. So that is very similar to that. Then there'll be this join method where we're squishing it all back together. And before you know it, we have a function here called reverse text. And we can actually put in booby trap and get back out party boob. Right? Booby trap. I'm not losing you, am I? So next up, let's check for some palindromes. We're not going to let any of those palindromes get by us because that's such a fun word. We have defined this function is palindrome. We're passing in an argument, meaning this block of logic is like a Tupperware container that's controlled and not vulnerable to the outside. And then we can actually take that thing that's passed in and run a method on it. A method's going to change it. It's an action. And then we put it into a new variable, which we can then even do more things on, like reverse. And yes, that's a way easier way to do it than the other one, but whatever. Sometimes we do it the long way so we can see more things. And then we put it into another variable, and we use this if-else conditional, which we'll learn in chapter 2, to print out other objects, string objects, and compare different objects to each other. Is the reverse list the same, double equal sign, you'll learn about that, to the non-reverse list? If it is, print yo. You got a palindrome on your hands. What do you think we're going to get? Taco cat is a palindrome. There's no back end and no front end to the taco cat. What about pluralization? Because don't you know someone that you're sick of that's always like me, me, me? That guy is usually named Bob. I'm sorry if your name's Bob, but it usually is. Bobs are just real selfish sometimes. So a Bob comes into your office and he's like, fix the company. I need to get paid more. But really, you know that there's 3 other people who are also named Bob and they're working really hard. So we can write this function called plural, and we can put Bob's name into it, which is what we're doing down here. We're calling this function. The function has to be defined first so that it can be called later. And when that word Bob travels in through this little opening inside of this container, it will go through a series of checks. And when this word moves down, it's first going to be checked. Does it end with a Y? If so, do this crazy thing. We're going to learn about list slicing later and how strings can be considered lists if you think of them as character by character. You'll find out that there's different types of slicing and we're setting special parameters there. We're using something called concatenation, actually tack the 2 strings together. But don't be deceived because a plus sign doesn't just do one thing in Python. It can do multiple things. And that is called the process of coercion. So anyways, let's put Bob in his place. I'm so sick of him being selfish. You know who's been doing all the work around here? The Bobs. All of them. Not just you, Bob. The other Bobs have been helping too. That felt good. It's pocket protector time. Let's play with numbers. Python can give us incredible tools to do calculator stuff you could never do, not even on a TI 95, not even a TI 103 if that exists, because Python is a coding environment. We can save variables and we can have 100-line scripts and we can import modules of functions and we can do all sorts of neat stuff. But we'll just start simple. Don't want to overwhelm you, but just know it's all in there. We can do simple stuff like multiply 3 times 3 using the asterisk symbol. We can take the power of something. Be careful with the power. In a lot of other programming languages or online, you'll see this is the caret icon, but in Python, it's a double asterisk. We can even get the square root of things, and we can get them out to incredible precision. We can actually specify more than this. It all depends on how powerful our computer is. So of course we can do calculator stuff, but we can even solve the Pythagorean theorem. Another important thing in chapter 1 is the idea of mutability, and mutability comes along with variables. It's about the states that a variable goes through, the changes. I always think of a caterpillar turning into a butterfly. It is the same creature, but it goes through different states of its life. And variables are the same way. We can assign a variable using this equal sign. It's the assignment variable in Python to the number 4, to the integer of 4, to be more specific, because it doesn't have decimals after it, or b to the integer of 19, whereas this would not be the integer of 19, that would be a float of 19. And when we run this cell, it doesn't look like anything happened, but we saved everything into those variables. And now we can actually just write the equation out. Pretty cool, huh? See you later, Pythagoras. We're moving on to generating random numbers. Now, we thought it was pretty cool earlier, right, when we were taking random letters out of a string. Well, we can do the same thing with numbers. We can specify the range. So if we import this random module, which is what's happening here, then we can use a method called randinit on it, meaning a random integer. int will be the short for integer. And when we run that, we get 18. Or do we? Let's run it again. Ooh, 1. Again, 11, 9, 7, 17, 7, 9, 18. Also, we might want to say between 1 and whatever the user inputs. We can do an odd or even test because, God knows this one always trips me up. What is that number? Even or odd? Big questions, big questions. But we can simply write apps, little functions and programs that can do that work for us. So here we've made a function called isItEven. And what we're doing, and that's what the DEF here is, it defines a function, chapter 2 stuff, but we bring in a number because there's no quote around it. That's the big difference between that. That is a string. That's closer to the number 4, like that. That is the number 4 in integer format. So we'll pass that into x here, and then we'll take x and we'll do %2. Ooh, what's %2? We haven't talked about that. Are you familiar with modulo? Well, it would be weird if you were, actually. Modulo is when you do division, but you throw away the actual answer and only keep the remainder. Not really that useful, you'd think. And it really, well, it is. No, I'm not going to say that. I like modulo, or modulo, as I used to say. Can 2 divide evenly into it? If it can, we know that it's even. And if it can't, then we know that it's odd. And over here, what we're saying is if it is not 1, this exclamation point equal is totally different than an equal by itself. Now it's a comparison operator, whereas by itself, it's an assignment operator. True and false. We get Boolean returns, a true and a false, kind of like a yes or a no, an on or an off, a 1 or a 0. And it's really cool because in Python, these true or false statements are keywords. You can see how it's highlighted here. When I type it like that, that means it has special meaning for Python, one of the Python keywords. Now, let's take the modulo operator to the next level. So here we have a list. Now, this is a very important noun, aka object of type list, that we will be working with in chapter 1. And it allows us to input a whole bunch of items called elements, and each one needs to be separated by the syntax of a comma. But you can think of this like a grocery list, and each of these integers are things that you need to get, like 1 banana, 2 apples, 3 Squeeze-Its, or whatever. And once we have this list, we can save it into a variable and then perform actions very similar to what we're doing here. We're bringing the list and processing it. It's not in a function this time, but it could be. So we take our list and we ask with a loop for each item in this list that's called old list. Look at each item and do your modulo comparison, and what result you get from that, see if it is equal to 0. Actually, probably you should put parentheses around these. If it is, if this thing is true, we end up getting something like that. And when Python sees that as the return from this calculation, then it will allow us to execute this code. It will not if it gets a false. It will skip that and go back up here. So think of this as like a wheel that's churning, and then if this key evaluates to true, then the lock will open and we have access to do this action, and that action append something to the list. And remember, this list right here is empty, so it will be like appending 1, and then maybe 4, and then maybe 7. So we'll end up with a list here that has just a few numbers, only when this part evaluated to true. So that's definitely more advanced than I was planning on talking about in this video. So remember, that's chapter 2 stuff. You don't need to know it. Wait, did I even talk about what happened? Yeah. Anyways, look, 2, 4, 6, 8, 10. Who do we appreciate? This list, the old list. Actually, screw that. 2, 4, 6, 8. Who do we appreciate? The even numbers, at least. Take me back to my cheerleading days. By importing a math module, we have access to a whole bunch of functions. Behind the scenes, what we're doing when we actually import something is we're bringing in a whole bunch of these DEF, and then some words and an input, but they're like containers of code that can be very, very useful. What sort of gives Python its power is how many of these kind of things you can import, and the power that has already been written by the open source community that you can bring in. And if you're curious about what these things can do, you can go to math, and then dot, and then tab, and you can see a list of all the cool actions. So this is all considered methods that are available. Or we can return the cosine of some amount of radians. There it is. Totally forgot how trig works, but we can cheat on our homework, probably because I was cheating on my homework using Python. Sort of funny. Okay, let's randomize a guessing game for our last thing with the numbers. So here's how our random guessing game is going to work. We, on the back end, are going to specify a number, but we don't tell our friend about it. And we like the number 3 in this example. And we're going to give him 10 guesses to guess what number is in our head. So we can write a little game like this. It says, well, there's guesses left. We start with 10 guesses. And then down here, each time there's a guess made, whether he wins or loses, it's decremented by 1. So that will become 9, 8, 7, 6, until eventually it will become 0. And when it is not greater than 0 anymore, we will go down into this block, and we will print you lose. But as long as there are guesses left, we're going to be using the logic that is in this area. One of the types, the nouns that we're going to work with, is called int, which is an integer, and another one is called input, which is a raw text input. This is what prompts the user to type something in. And then what they type in, we convert it. Whether it's the word ONE, it will try to convert into the number 1 so that we can do some math on it, and then save it into this variable. The variable will come down here, and it will say if that variable is equal to, because you'll notice the 2 equal signs, the random number, which is the one that we specified up here, 3, then we will print you win, and the word break will stop the loop, so we don't continue on. And then if we don't break, meaning that he guessed but it's the wrong number, it will skip this second indentation, go down to this variable here, and then -1 from it. And that's why that notation is a little funky looking, because what it's actually saying is whatever this number is, subtract 1 from it. And then eventually we might get to 0, or our friend might be a winner. So we know it's number 3, but we're not going to cheat. Maybe he's like 2, it's my favorite number. And you're like, ah, dang. Maybe 5? Gosh, you sure you're thinking of a number between 1 and 10? Maybe 7? Nope. And then all of a sudden, on his 4th try, he guesses 3. Boom. You win. And had we tried 10 times unsuccessfully, we would have eventually got it to print, you lose. So there we go. A fun randomized guessing game. So these last 2 sections are really where you start kind of seeing the power of Python after this beginning course. So once you're done with this entire course, we really just open the door to all the truly amazing stuff Python does. I mean, in reality, not many programmers are doing the basics. They have to have those to understand how a lot of the next steps are going to go. So here is where we're going to start pushing a little bit into what you actually do with Python. How many times in your life have you thought, man, I am sick of writing out the Fibonacci sequence? Yeah. Me too. Did you know Python can do that for you? Look at this. We have 2 variables here, which are both nouns that we're going to learn about, objects of the type, whatever we put into them. And in this case, we're putting in 2 integers. Although looks a little weird with the commas, is the same thing as A equals 0 and B equals 1. And then we're doing a for loop, something we'll talk about in chapter 2, and we're checking, is this item in the range? And range is going to create a list between 1 and 15. So there'll be 15 times that this tire spins, that this loop happens, that this sequence is played through. So a little tricky, don't have to know it, but just really quick. A starts as 0, B starts as 1. For 15 times in a row, what it does is it adds A and B together and that becomes the new B. And what do we get? The Fibonacci sequence. And remember how it works is you add these two. 1 plus 1 is 2, and then 2 plus 1 is 3, and then 2 plus 3 is 5. So we're going to look at the Fibonacci sequence a number of times. We're going to learn 5 different ways to do the Fibonacci sequence that demonstrate different styles of programming in the 3rd chapter. And we have some really cool things in the loop section that we can learn about this too. So what about FizzBuzz? You might have heard of this. This is probably the lamest and most popular thing ever get asked in your job interview, and it probably will come up because you know how lame a lot of recruiters are. When they're looking for a programmer, they don't know what they're doing, and they go online and they read like, how do I hire a programmer? And it says, ask them if they can do the FizzBuzz problem. You might even get asked to code it like on a whiteboard or something. So what is the FizzBuzz problem? Well, the way commonly the recruiter will say is, can you solve the FizzBuzz problem? Meaning, have you heard of it? And then if you haven't, they'll say, oh, well, the way it works is that we need you to go through some kind of range, usually like 1 to 100 or something. And if the number is divisible by 3, print out the word fizz. If the number is divisible by 5, print out the word buzz. And if the number is divisible by 3 and 5, print FizzBuzz. There's so many ways to solve this, but one of the easiest ways is to use the modulo and just check. Like run through this number, this range 1 through 11, and for every number, 0, 1, 2, 3, 4, 5, come down here and say, is it modulo 5 equal to 0 and 3, then print FizzBuzz. If not, just fizz. If not, just buzz. And you check for 3 and 5 down here. One of the things I want you to take away from this video is this sort of hierarchical way that we're going at it. Like the most complex thing comes first. And then if it doesn't fit that characteristic, then we check these two. But they're sort of equivalent because they're just 2 different numbers. But it wouldn't make as much sense to move this one down here. And then also if you look at the elif for else if, and then else is sort of a finally type thing. And once again, that's chapter 2 stuff. I want to show you the solution to FizzBuzz. 1, 2, fizz. 4, buzz, fizz. 7, 8, fizz, buzz. Solved. Where is my job? Okay, now it is time to get to the payoff. When I'm completely done with this course, I'm going to start working on another course which is specifically about TensorFlow, which is Google's machine intelligence software. And we're going to look at using Python to create neural networks and AI stuff, but that's just the particular branch I'm most interested in. After this basic programming course, you can take it in any direction you want, whether you want to go into video games or data science or any of these things. So I'm going to show you a few hints of where you might go, and you'll understand some of this, but some of it we won't cover. Okay, so first off, I want to warn you that if you follow the tutorials, you might not be able to run all of these things because they require importing modules, like this import time. If you downloaded the Anaconda package like we had, you have time, but there could be an instance where you run one of these cells and it says missing the package time or module time. And then we also have videos on how to update those, but just know that's going to be the reason why some of this may or may not work. Now that that warning's out of the way, let's check if it's dark outside. There's a cool little program I found. Somebody else wrote it. But we import the time module, and then we print out that it's dark outside. We have an escape character. This is something special that lets us break out of the string and add new lines. And then we define this variable here, and in the same way we had a list earlier on, there's something called a dictionary. This is another noun we're going to learn in chapter 1, and it holds key value pairs, so key and value pairs. You're going to look at the different way we can construct this, the indentations and the spacing being very important for the way it works. You can't just mess around with that and throw it off like that or something. And then we create one dictionary for dark, and we have another dictionary for light. And down here we say, what time is it right now? This is .local time. It's a method that comes with the time that we input. Then we bring it over here into a variable, and we do some math on it. And we say if, and this whole little thing of logic, if the time right now based on the hour is greater than or equal to this dark time dictionary up here based on these numbers, or blah, blah, blah this, or blah, blah, blah that is less than that, print yes or print no. But the result is really cool because right now, it is 3:02 p.m. It is light outside. And watch this. Is it dark outside? No. It's not dark. It's actually bright. And it really will know when it's not. So think about that. You could build a cool little app that knew exactly what was happening with natural lighting in someone's room. Maybe you think about that in a way to build some kind of gadget. Imagine programming a new light switch in somebody's house that knows if it's dark or not and just turns the light on, saves power, something like that. Easy enough to do. Now, how about reading a spreadsheet from the internet? Now, Pandas is a different library than anything we're going to cover here. Libraries being these big sets of pre-built code that have all this sort of way of working with each other and usually specifically solving some kind of industry's problem. And one of them, called Pandas, lets us do super amazing things with spreadsheets. It's sort of a data science tool. It evolved from a big hedge fund that was using it to calculate and make decisions on tradings. One of the cool things we can do is we can go onto the internet and read a CSV file. This would be the equivalent of Microsoft Excel, if you're not too familiar with a CSV file, or a spreadsheet like a Google spreadsheet, something like that. And this is not hosted on my hard drive. I'm not reading it off my computer, although we could do that too. But this is actually going out on the internet and bringing it in. And look, we have all of the information from the spreadsheet. And we can do tons and tons of stuff with this. I've thought about making a series on Pandas because it's a really powerful module and it can do cool stuff. And if you're going the data science route, it's going to be a big one. Now, another really neat thing we can do is make a progress bar. One of my personal favorites. It comes from a package called TQDM. Definitely probably won't have this unless you install it specifically. So here I'm specifying a loop. Imagine like a tire on a car spinning, and I'm saying spin 10 million times. And each time you spin, do nothing, but just spin again. And that takes about maybe 5 or 6 seconds for my computer to do. 10 million's a lot, a lot of calculations. Very simple thing it's doing, but it's still a lot of rotations and it takes time. So this module lets us actually have a little bar that shows the user how long it's taking to do something, because how often are you waiting on your computer? And it's always nicer when you can see a really accurate bar of how much longer it's going to take. So when we run this cell, you can see 60, 70, 80% done, and finally it completes. Pretty neat, huh? You have to put at least 10 million rotations in here. So make a progress bar. Another very cool thing we can do with Python. How about scraping jokes off a website? Someday, when I get to this machine intelligence course, one of the projects we're going to do is we're going to go to the internet and we are going to scrape a whole bunch of jokes. We're going to feed them into the machine so that it can make its own jokes. It's going to learn how to make jokes on its own using a neural network. One little piece of it that I had a lot of fun writing was this joke scraper. And you can imagine how many things on the internet you might want to go scrape. Like video game ratings, and you're like, oh man, they don't have a way to download all this data, but I would love to have it for my podcast or whatever it is. So you can go into Python and you can import a module called BS4. It's called Beautiful Soup 4, and it gives you the power to go out onto the internet and download whatever you want. So here we're actually going to this website called victorianhumor.com. Okay, these are all just Victorian humor jokes. I don't know if you're into Victorian humor, but it's like a long list of them, kind of like a database. But they don't really let you download everything, so I don't have like a download CSV file. So I had to write a script that went into the page, it looked at the div tags that hold this piece in this area of the page, and then it had to go to the next page and then pull off all of these things going down. So I had to write a script that would find this special section of the page and omit all this stuff, the from and the date, and then go down to the next one and take that, and then even go press next when it's done with this page, and then get everything here and put that into a nice format. And you can see I did it in so few lines of code. I mean, this is a really powerful module here. Really powerful package. So we put in the URL that we want, we send out a response. This is part of what it needs to go out onto the internet and look like a web browser. It has to have some header information here. And then we simply use Beautiful Soup's function and special response method that lets us do a few things, and we specify an argument so we know what kind of page it's looking at. And then we come through here and find everything that has J inside of the HTML. Is that too much? Yeah, it's probably too much to get into, but all pages on the internet are done with HTML, and that's part of the way you can specify parts of the HTML. And then I just said for joke in J array, meaning a for loop, meaning like that tire, just circle around. Each time grab the joke and put it onto a big list. So, and check it out, it went out onto the internet and got all of those jokes. We have a limit on it, but it can just go page after page after page. I mean, you can get millions or billions, as many jokes as there are out there in just a matter of seconds. So you can see how powerful writing, once you're a bit more familiar with the basics of Python and can go out there and grab that stuff on your own. So very powerful stuff, the ability to scrape the internet using Beautiful Soup. Now, another thing you might want to do is share your data. Maybe you've got some awesome thing you're collecting, like you've got an app and you're getting user information that you want to build a platform off of. Other people want to build on top of your stuff. So you need a way to build an API for them, an application programming interface, so that they can log on to your website, get your data, and build cool things on top of it, which will further entrench the value you have. Maybe you want to charge for it someday. You can do really cool things with Python to create data that way. We're going to import some modules like JSON, which is the way APIs are often created on the internet to be accessed, and then something called collections, which gives us a really powerful way to work with dictionaries, kind of more advanced than the normal dictionary. And one thing we can do is we can actually specify with brackets these layers of information that come out in a structure that can be used for somebody else. So when I run this cell, you'll see that we actually get valid JSON. So if you go to Twitter and sign up and you build an app that uses the Twitter API, you're going to see stuff just like this. And you can actually make it yourself. Maybe you can be the next Twitter. Make your API so other people can build on top of it. Very cool. And of course, like charts, you think of programming as being so boring and bland and text-based, but there are some really beautiful modules out there. There's one called Seaborn, there's a really classic matplotlib, and there's very cool dynamic maps and things like Plotly that you can plug into to take your data and turn it into visual stuff, including an entire thing you can use with games and something called Turtle that can do cool graphics. Simply, right here, we're using something called NumPy, which is a different module that allows us to do some kind of matrix multiplication stuff. And we're looking at some scatter plots down here using PLT, which allows us to do graphs, things like that. You can see that it generates its own data up here. We could always bring in data, maybe using pandas or something like that. We can just create a bunch of random data and put it on a graph here. Think about how cool that is. You could build something like this and then go realize what kind of data you need to populate it in a way that's actually useful. Hopefully that gives you a little bit of a taste of the stuff we're going to be learning to do, and we're going to keep revisiting this exact same document. So we're going to get more and more familiar with these programs throughout our course. And this is going to set you off in a great first step towards building a lot of really cool things that I call oysters. Why? Well, because the world is your oyster. From here, you can move on to robotics, to gaming, to data mining, to website building, to artificial intelligence, financial engineering, or just working and building apps with APIs like Twitter and Facebook and banks and all that cool stuff. So each of these is going to have different libraries you're going to want to get familiar with as the next step after this Python basics course. My next one I'm going to teach is going to be on artificial intelligence, and specifically one segment of it that's done with Google's open source project TensorFlow, which is written in Python, and the way we can build neural networks and the power of them. Congrats! You made it to the end of the lesson, and also to the end of Chapter 1. Now we're ready to learn about the verbs of programming, so we actually get to see the actions that we can take with all of these new tools, like how wrenches turn bolts, screws tighten loose parts, and drills can release tires. So without further ado, I present to you Chapter 2, the verbs of programming. Subscribe to the Mnemonic Academy YouTube channel for daily uploads that will help you learn amazing concepts through effortless associations.